tangent and normal to a hyperbola. Okay, so we know hyperbola equation is x square by a square minus y square by b square is equal to 1. Now let's find the slope. To find the slope, we differentiate with respect to x. So that when we differentiate, we get 2x by a square is equal to 2y by b square. This is minus dy by dx is equal to 1. Minus 2y by b square dy by dx is equal to minus 2x by a square. Now let's remove this from here and bring it to this side, times minus b square by 2y. So 2 gets cancelled, minus gets cancelled. So dy by dx, which is the slope of hyperbola, is equal to b square by a square times x by y. At x1 comma y1, the slope would be b square by a square times x1 by y1. So the equation of the tangent would be y minus y1 is equal to m times x minus x1. So let's substitute m by this slope. So b square by a square times x1 by y1 times x minus x1. Okay, let's simplify. A square y1 minus a square y1 square is equal to b square x1 minus b square x1 square. B square x1 square minus a square y1 square is equal to b square x1 minus a square y1. Now let's multiply this whole thing by 1. So we get a square y1 square minus b square x1 square is equal to a square y1 minus b square x1. Now let's multiply it by a square b square. So a square gets cancelled, b square gets cancelled, a square, b square. So now we have y1 square by b square minus x1 square by a square is equal to y1 by b square minus x1 by a square. Okay, I think we should not have multiplied by minus 1. So since we shouldn't have done it, let's redo it to get back there. So now what happens is x1 square by a square minus y1 square by b square is equal to x1 by a square minus y1 by b square. Now this is 1, right? So this is nothing but a point on the hyperbola. So now let's write it like this: x1 by a square minus y1 by b square is equal to 1. So that is the equation of the tangent to the hyperbola at x1 comma y1. Now let's look at the equation of the normal. Now slope of the normal would be minus 1 by the slope of tangent. Yes, the negative reciprocal. So which means this would be minus 1 by b square by a square times x by y. So which means this would become a square by b square times, this is x1 by y1, because we are interested in at x1 comma y1. So x1 and minus. So this is the slope of the normal. So now equation would be y minus y1 is equal to x times, m times x minus x1. So y minus y1 is equal to, slope is minus a square by b square times y1 by x1 times x minus x1. Now let's simplify. B square x1y minus b square x1y1 is equal to minus a square xy1 plus a square x1y1. Let's bring x1y1 to one side. Okay, so a square xy1 plus b square x1y is equal to a square x1y1 plus b square x1y1 divided by x1y1. So x1y1. So now y1 disappears, x1 disappears, x1 y1 x1 y1 both disappear, x1 y1 x1 y1 both disappear. Okay, now this looks like a square x by x1 plus b square y by y1 is equal to a square plus b square. So this is the equation of the normal to the parabola. Now let's look at the coordinates in parametric form of the equation. At theta, that is a sec theta comma b tan theta. So let's look at first equation of tangent. So slope of the tangent, we have already evaluated it or derived it, b square by a square x by y. Now we substitute x by x, so a sec theta by a square times b tan theta. So one of the b's cancels, one of the a's cancels. So our slope of the tangent is b sec theta by a tan theta. Now that we have the slope, let's find the equation. So y minus y1 is equal to m times x minus x1. So y minus y1 is equal to, slope is b sec theta by a tan theta times y minus, x minus, and here y1 would be b tan theta. So now let's simplify. A tan theta y minus ab tan square theta is equal to b sec theta x minus ab sec square theta. See, while writing this itself, you should suddenly be able to recognize that somewhere sec square tan square. So some identity of that would come up. So let's bring b sec. Let's bring in b sec theta x to this side. ab is common to both. So tan square theta minus sec square theta. Now, if you are very confident that this is equal to 1, you can go ahead. But I am not very sure. So, what do you do? Very quickly simplify it and see. Sec square theta by cos square theta minus 1 by cos square theta. So, gives you sin square theta minus 1 by cos square theta. Now, sin square, we want 1. But this is sin square theta minus 1 is not 1. 1 minus sin square theta is 1. So that means we have to reverse this sign. So let's multiply the whole thing by minus 1. So b sec theta x minus a tan theta y is equal to ab sec square theta minus tan square theta. This is going to be 1. Now we can divide this whole thing by AB. So AB, AB, BB, AA gets cancelled. So sec theta, x sec theta by A minus y tan theta by B is equal to, is also by AB, 1. So this is the equation of the tangent in parametric form. Now let's look at equation of the normal. Slope of normal would be equal to minus 1 by b square by a square x by y, which is equal to a square minus a square y by b square x. Now let's do the substitutions. Minus a square y is b tan theta by b square a sec theta. So one of the b's, one of the a's. So the slope of the normal is minus a tan theta by b sec theta. Actually, we could have directly taken the reciprocal of this. Okay, no problem. Let's continue. Now the equation of the line would be y minus y1 is equal to m times x minus x1. So now let's do the substitutions. Y minus b tan theta is equal to minus a tan theta by b sec theta times x minus x1, that is a sec theta. Simplify. B sec theta y minus b square sec theta tan theta minus ax tan theta plus a square sec theta tan theta. Ax tan theta plus by sec theta is equal to a square sec theta tan theta, sec theta tan theta are common. So plus b square sec theta tan theta. Now let's divide the whole thing by sec theta tan theta. So we are left with ax by sec theta plus by by tan theta is equal to a square plus b square. So this is the equation of the normal of a hyperbola at x1 comma y1. I think that's enough for today. Bye.